Have you ever wondered how a tiny atom can release a tremendous amount of energy, as in the case of nuclear reactions? The answer lies in one of the most famous equations in physics, E equals mc squared, otherwise known as Einstein's Mass-EnergyEquivalence principle. To understand this, imagine a seesaw in a playground. On one side, you have mass, represented by a big, hefty sandbag. And on the other side, you have energy, represented by a pile of feathers. At first glance, you might think that the sandbag will always outweigh the feathers. But what if you had an enormous amount of feathers, a mountain of them? The seesaw would tip towards the feathers, right? This is the essence of Einstein's equation. Mass and energy are two sides of the same coin, interchangeable under the right conditions. The m in the equation stands for mass, like our sandbag. The E stands for energy, like our mountain of feathers. And the c squared? That's the speed of light, a really big number, squared. So, when you multiply a bit of mass with the speed of light squared, you get a lot of energy. That's why a small amount of matter, like in an atom, can produce a large amount of energy, like in a nuclear explosion. But remember, this conversion doesn't happen in your everyday life. You can't turn a cup of coffee into a bolt of lightning, because we're dealing with the speed of light squared, a number so big that it's almost unimaginable. This equation comes into play when we're talking about things on a cosmic scale, like stars, or on a very small scale, like atoms. So to sum it up, the principle of mass-energy equivalence tells us that mass and energy are two forms of the same thing and can be converted into each other. It's like having a pile of money in one hand and a credit card in the other. They're different forms, but they're both wealth. This idea, born from Einstein's mind, has revolutionized our understanding of the universe, leading to advancements in physics and technology that continue to shape our world.